No, I'm not watching you at all.
Well, I'm just making sure that that's not hitting my.
Oh, it came to your head.
Okay. Oh, I thought he was trying to get your attention to quit playing games.
I think he was doing an audio level check.
Oh, yeah. Good call.
Oh, sorry, the other floor.
The other Florida?
That's the one owned by Spain. That's the one owned by Spain.
Oh.
Yes, very, very good. That's very historical moment.
Ezra, what does happen to just got new laptops.
I thought that they would come. I thought the Windows ME.
We could provide that for you if you miss it. Welcome to the October 2011 Omaha Linux User Group meeting. I am John Larson, the Systems Engineer at the AIM Institute.
Hi, John.
Welcome to training. Hello. Has there been any? Let's see, what happened today? Oh, Fedora 16 beta came out today. I only got so far and it crashed on me. But
And
more of my
West
hardware.
Coast fruit company announced a new phone.
Yes, it's a West Coast
An evolutionary phone,
evolutionary phone. That's right, not a revolutionary phone.
not an L.
It evolves as you use it.
Now, do I have?
It used to be a
So-
reptile and balance processing.
Next week at GN Mug, do I have to talk about that?
I would.
Okay. You gonna give me some slides?
Just bring out that whole horse lines.
Change a couple of things.
This
and,
week at GN Mug, we'll be watching the keynote.
Actually,
Well, wasn't Google supposed to come out with the Prime about the same time that the iPhone 5 was now?
That's the rumor. There are some pictures that have shown up today on Droid Life that show the purported Nexus Prime. So,
But it's black.
speaking of old names, the Nexus, of course, there's the third one. There's a rumor of a new phone from Motorola called the Droid Razr.
Oh my god.
yeah.
R-A-Z-R. Now that might be the European name. It might be Droid HD over here, but that's supposed to be something else as well.
Maybe the Droid XP.
Guess it's better than Droid 7
Or
or
Sempron.
Droid Vista.
The Droid
I think I
It's
read.
supposed to back up.
Yeah, I just read that last night on Identica that Kernel.org was back. So
I've never heard if they figured out what the heck happened. But it's mostly backed up. I don't know if that means they got everything solved for backup or what.
no, possible. Maybe they got some donations for hardware too.
Kernel.org. Let's see what is that? Netcraft. Let's see what it's running now.
Netcraft.
Yeah, we're gonna see if Kernel.org is running OpenBSD.
Oh, look, it's IIS.
Maybe that's what happened.
You remember the old Apache hack from 2001 where they broke in and they replaced the Apache Feather icon with Microsoft Office powered by IIS? Awesome, isn't it?
Oh, that's good.
What you do with the old computers?
According to Netcraft,
They're
it's
a box.
Fedora.
What are you doing?
Use them for labs. They still have a purpose in their life, unfortunately. Let's see. Talked about that. Okay. We'll go straight into it. How?
Okay.
SELinux.
Ah.
You can introduce them.
How?
College.
These guys were.
God, I was here last month. You don't remember? Gee.
No.
You're the same, we're different.
Well, there are a few people I recognize in the audience.
So who wasn't here last month? Raise your hand.
More than half the room.
Craig.
How?
Should have been here.
I know. I was in Florida.
Okay,
Wasn't
so
that fun?
for those of you who weren't here last month, get out. No. So my name is Hal Pomeranz. I am aware of many hats, but I've been coming here to Omaha for a long time, working on a case with law enforcement here in town, off and on for the last 2 years, and it occurred to me over the summer that I'd never actually given a talk to the local Linux user group, so I contacted John. John said, Sure. So I showed up last month and gave a talk on forensics, and that went over so well that John said, Hal, you're going to be here in October, so talk about something else. So I said, sure. So we sort of took an informal poll at the end of last month's meeting and decided the topic was going to be SELinux, which is a subject that I'm on sort of an evangelical mission about these days. I realize for a lot of people that their only interaction with SELinux is it's that crazy thing I've got to remember to turn off whenever I install a new Linux system.
SELinux equals disabled.
And I mean, I get that. I mean, really, I understand where that comes from, because probably, you know, at one point you decided, oh, what the hell, let me just try turning it on and see what happens. And then, like, everything exploded on your system, right? And so you immediately turned it off, because there's no significantly useful documentation out there. The error messages are completely mysterious. You have no idea what's going on. And that's fair. So what I'm here talking about today is at least give you kind of a basic intro to SELinux, teach you how to figure out what's going on with SELinux, some common troubleshooting strategies, so that you can hopefully make an informed decision about turning it off. You know, I'd like you to at least, before you turn it off.
Well, I understand why it's broke now.
Yeah, and I'm still not going to use it, right? I mean, that'd be okay with me. I mean, that would be better than where.
Yeah.
I mean, seriously, you know, I mean, I first poked with SELinux, I don't know, you know, many years ago, probably, you know, 2004 timeframe, and it was just a catastrophe. It's gotten much better, you know, in the last 6 years or so. Mostly because I think there's been a realization that most of the world doesn't live in an environment like the NSA, which is where SELinux came out of. And so we've developed what's called targeted policy for only controlling sort of the important services on the box with SELinux and letting the rest of the stuff work reasonably normally. And so that's made things better. There's also been sort of a core development group that's been working on improving the kind of baseline policies for SELinux. So mostly policies kind of work out of the box now, which they didn't before. So really it has gotten a lot better, and it, you know, be worth maybe taking another look at if you looked at it a few years ago and gave it up as a bad job. So what I'm going to be talking about tonight is actually the first part of a full-day class on SELinux that I actually teach. So we're just going to cover like sort of the first 2 bullets here, basically sort of an overview about what SELinux is and how we got here, and then you know, some quick troubleshooting examples so that you at least get a feel for how SELinux works. All right, so what is SELinux? All right, so first off, SELinux is a kernel-based security policy framework, basically. And it can actually do several things, although most people only want it for one thing, which is the sort of application whitelisting functionality that we'll talk about in a minute. All right, so what can SELinux do for you? Well, okay, so SELinux shows its heritage coming out of NSA land. It can do what's called multi-level or sometimes multi-category security. Basically, when I say that, what you should think about is sort of the normal classification system, you know, unclassified, secret, top secret, that kind of thing. So the idea is that you can actually mark files on the system as being in like top secret category. And for users on the system who don't have authorization to look at the top secret data, those files literally don't exist to them. I mean, the kernel basically hides that data from the lower privilege level users. I've often thought that, you know, it would be a cruel kind of capture the flag exercise in one of these, you know, DEF CON challenges to set up a Linux box where the flag was hidden at a high SELinux security context, because nobody in the world would be able to fucking find it. I mean, seriously, you know, most people just like don't know how to deal with that. So
until someone does set enforce disable.
Well, yeah, right. I mean, until somebody figures out, oh, hey, SELinux is running, maybe I should turn that off. yeah, then maybe they'll find the file. So yeah, I mean, most people just don't use multi-level security in their normal job, and so the way we deal with this in kind of modern SELinux implementation is that by default everything's just at the lowest security level, and so you don't care that the system's doing multi-level security because everybody can see all the files, right? So yeah, that's mostly what we do in practice, unless you happen to be in one of these kind of black projects where they care about multi-level security. Most of us don't. All right, so the second thing that SELinux does is what's called role-based access controls, or RBAC for short. Okay, so we've understood for a really long time that the problem with the Unix security model is that it's sort of all or nothing, right? So somebody needs to be able to mount a file system, and you have to be root to mount file systems. So in the olden days, if somebody wanted to be able to mount a CD-ROM on their desktop, you would have to give them the root password. And that'd be great. I mean, they could mount their CD-ROM or whatever, but the problem was, of course, then they could do all the other things that root could do, look at other users' files and, blow up the system and all that stuff. So, I mean, that's an issue, right? Lack of granularity of control. So role-based access controls basically attempt to address that issue. Basically, the idea is that you separate administrative privileges into roles. So there might be a role that's like the network administrator role, and that person can up and down network interfaces and set network parameters. And there might be another role that was the user administration role, who can add and delete users and change users' passwords and stuff like that. And another role that might be like, I don't know, printer admin or something like that. And so the idea is that you basically separate out all of the normal powers of the administrative user on the system into these roles, assign people to roles according to their job function, and do away with the traditional Unix super user account. Okay, that's the sort of perfect world scenario. The reality is that creating a policy like that, a role-based access control policy like that, is really hard. And I think that even if you could do it for a particular site, it would be so site-specific that it wouldn't be sort of broadly portable across a wide range of sites. And the other problem is, okay, so let's suppose I could define a SELinux role-based access control policy just for my site. Okay, that would be great for all the boxes that are running Linux. But if, in my world, I typically am going to have, Solaris and, maybe HPUX and AIX and all that stuff. And all of those operating systems have some form of role-based access controls built into the kernel right now. But of course, the configuration language is completely different from platform to platform, right? This is one of the most sort of vendor-dependent areas. And so even if you come up with a policy for your Linux boxes, you then have to go through all the work of porting that policy to each of the other platforms that you supported. It's a catastrophe. And so most people don't do this. They use sudo instead, which gives them sort of 80% of the functionality, but it's portable everywhere, right? And it basically works the same. So yeah, I've never seen a site that really goes hard in for role-based access controls. And so you can ignore it. You can just not use it and just stick with sort of your normal super user thing in Unix, and you'll be fine. So what's really interesting about SELinux actually is this thing called type enforcement, which is really application whitelisting, which is kind of a hot area in security in the last few years. Basically, the idea is, all right, you've got a process like a web server, and really, for most applications on your system, it's pretty easy to define the things that application should be allowed to do, right? A web server, it reads configuration files from a particular directory, and it has some HTML documents from another directory that it needs to read, and maybe it needs to execute some server-side executables from a different directory. And it's got some log files that it needs to write in some directory. And obviously it needs to be able to sort of connect to the network and do HTTP. But really, aside from that, that's all, right? And so the idea is you write a policy that says, okay, allow the web server to do these things. And then if the web server is ever compromised by an attacker who tries to do something else, like execute other programs in the operating system, or set up a reverse tunnel out to some command and control server, the policy doesn't allow the web server to do those things. And so the kernel says, oh, you're not allowed to do that. It says, permission denied or access denied to the application, which more often than not causes the application to just blow up. So the idea is you write kind of a default deny policy for your applications. Okay, you're allowed to do these things and nothing else. And then the hope is that that will prevent attackers from doing nefarious things on your system via those applications. And given sort of the increasing sophistication of attacks, I think this is the right way to go. I mean, the way we are right now, we're in this kind of reactive security posture. I mean, it's kind of like, living with a default permit firewall. Oh, look, you broke into me this way. All right, so I'm gonna put a Band-Aid on the system that prevents that attack from happening, right? Oh, you broke into me another way, It's like, oh, okay, I'll put a Band-Aid on the system. I mean, that doesn't scale, right? Especially at the volume of attacks that we're seeing. So I think you're better off, doing it the sort of default deny way. It's like, okay, you can only do these things, and everything else is just forbidden, and gets blocked. So I think application whitelisting is sort of a better approach than kind of signature-based defenses or kind of these one-off kind of Band-Aid defenses. But your mileage may vary. So when SELinux was first rolled out of the NSA, they tried to do everything, right? They tried to sort of boil the ocean. And everything on the system was tightly constrained by these SELinux policies. And it was just a catastrophe, right? Because while I can tightly constrain what a web server on a box might be allowed to do, it's really hard to write a policy for what a user on the system might want to do, particularly a sort of power user kind of person in a typical Unix environment. And so what would happen was, the default policy didn't work for any site because it didn't cover all the bases, and people just ended up, turning off SELinux. And I mean, there's a really interesting sort of historical document on the Fedora wiki where Dan Walsh, who's one of the engineers at Red Hat who's working on SELinux, said, so we took a step back and we tried to figure out what was important. What was the important part about SELinux for most people? And the important part was, targeted enforcement, but not for all applications. It was for the applications that external attackers were most likely to go for. And so what they did is they created this thing called a targeted policy that only applies to sort of network-facing applications on the box. Everything else, stuff that's run as normal interactive users, is not constrained by the default targeted SELinux policy. So normal users can go off and do their own thing without being whacked by SELinux all the time. It's just the sort of entry points that an external attacker is going to use that are sort of managed by SELinux now, which again, I think is a sort of a lot saner world to be in. So, and the policies are better written, so they cover more of the common bases. So anyway, works a lot better now than it used to. Okay, so to orient yourself in the SELinux universe, the first thing you have to understand is this notion of objects and their contexts. Okay, so an object in the SELinux universe is, well, pretty much anything in the operating system. Files, directories, devices, network sockets, users, all of these are sort of objects in the SELinux universe. And all objects have a context. And look, context is nothing more than a label. It's just a string that's applied to that object. And it's, the names of the strings could be anything. I mean, you could call, them Bob and Hal and Chuck and Mary. But what we've developed over the years in SELinux is a set of conventions for naming these contexts, so that everything sort of follows this pattern. And once you kind of wrap your head around the pattern, it starts to make sense. And I'm going to show you a whole bunch of examples of context. So we'll pick up context as we go along. All right. So every object in the operating system is labeled with a context, some some string that describes the object. SELinux policy basically are rules that allow objects in different contexts to interact with one another. All right. So, for example, I've got a web server, and it's a process that's running on the system. It's an object. It has a context. All right. So the web server is running in the context HTTPD type context. Let's just say. Okay. The policy rules for SELinux describe what that process running in HTTP type context is allowed to do. So it might say, I allow a process running in HTTP type context to read files from the etc HTTPD directory, which has context HTTPD configuration type or something like that. And I allow them to read files from the document root, which has HTTP document type context. And I don't know, maybe they're allowed to execute files in CGI bin that have HTTP exec type context. Okay, so that's really all the SELinux rules are. You've got objects with names, and then you say who's allowed to do what to whom based on the names. Okay, so it's all based on these context labels that are applied to the objects. And the whole shooting match as far as defining SELinux policies and troubleshooting SELinux is dealing with these blackball contexts that have been applied to all the different objects in the operating system. Now, the thing that makes it sort of more difficult is that these contexts for SELinux land live completely independently from the normal Unix file and directory permissions that you're used to dealing with. So the reason that your web server might not be able to get files out of its doc root might be because SELinux is turned on and it's blocking access to the document root, but it also might be that you just like accidentally chmod 000 your document tree and the web server can't read it, you know? So it complicates troubleshooting because you have to figure out, is this an SELinux problem or is it just like a normal Unix problem that I screwed something up, right? So you've basically added another layer to your troubleshooting process, which doesn't help you. Now, if your system supports SELinux, then the commands in your operating system have the magic minus capital Z flag, which shows context, and right, everything has a context. So let me show you some examples, which will make this whole context thing a bit clearer. All right, so for example, I can do really. Good enough. All right, so I can do a PS minus EZ, and it changes the output of PS so that now out here in the left-hand column you see all of the context associated with the various processes. So contexts in the SELinux universe are normally written as these tuples. Okay, so you've got basically 3 sections plus the security level. That's what the S0 is. You'll notice everything's in S0, which is the lowest security level. So we basically pretty much ignore the security level. Now, the 3 sections of the context, you see, you know, system U, system R, kernel T. Okay, so this is the user and role portion of the context, which is when you get into role-based access control, that stuff is important to you. But since we're not leveraging role-based access controls, you can just ignore that stuff. Generally speaking, as you'll see as we go along, most objects that are sort of in the operating system end up being in something like system U, system R, the sort of generic system user context and roles. The part that's important for the type enforcement, application whitelisting stuff we care about is the third portion of this tuple, which is the type field, basically. Right? Now, again, I mean, this naming convention with these sort of 3 sections separated by colons is purely conventional. I mean, it's just a naming scheme that we came up with in the early days of, I shouldn't say we, they came up with in the early days of SELinux. I mean, really, these labels could be completely different, but this is the sort of system we've gone with. But again, for type enforcement, really the part you care about is this third column. And so, as we go down through the process list, what you'll see is that there's basically a different type for each process. So these are all the spontaneous processes that are spawned out of the kernel. And so they're all in kernel type. But as we go a little bit further down, you'll see that, for example, everything, like here's cupsd, right? And it's in cupsd type context, right? RPC bind is an RPC bind type context. So the naming convention that we follow generally is that a process that's, is process X is in X_T context in general, okay? And that's how we differentiate the different processes. Look, it's my demon. It's the HAL demon. All right, so all of the system processes have their own context, but when you get down to where my processes are for my, Windows and my shells and stuff like that, what you see is there's an awful lot of processes that are running in this unconfined context, and this is how targeted policy with SELinux works, okay? So system processes, the things that are going to be controlled by the targeted policy, all have their own type, like audit D type, right? But processes that are running as normal users on the system, processes that are started interactively, or processes which aren't network facing, aren't constrained by the targeted policy. So they just run an unconfined type. And there's basically a global rule in the SELinux policy that says anything that's running an unconfined type is allowed to do anything it wants from an SELinux perspective. Now, normal Unix file and directory permissions still kick in, but this is basically how we've sidestepped the SELinux issue for sort of normal user processes. We just let normal users run in the unconfined role, and SELinux basically ignores them.
So do you like questions at the end or during?
No, jump in anytime.
So if I've got a nice blank box, I can install some distro targeted execution on it. And now I want to do something with Apache Tomcat because I'm a Java head.
Right.
Can I just go get a targeted execution policy for Apache Tomcat since that's such a common thing? Or do I have to write one from scratch?
No, the default policy set that comes with the distros that are big into SELinux, which has typically been Red Hat and Gen 2. The default policy, which is referred to now as the reference policy, already includes policies for most of the common services that are included with that operating system. I mean, there's definitely a policy for Apache, and I'm pretty sure Tomcat is also there as well. Where you run into problems with not having a policy is for things that don't come with the operating system.
Like Tomcat.
Well, Red Hat has a Tomcat package.
I never installed through package.
Okay.
I just grab it.
Okay. Well, yeah. No. So if you grab it from source and build it and put it in, you will probably run afoul of the SELinux policy on the system if you turn it on in enforcing mode. So yes, you could run into problems with that. Third-party software, Oracle, SAP, the commercial ISVs, they don't ship with, SELinux policies for their application. You get to figure that out for yourself.
But if the policy is specific to the process that's running, why would it matter if they're using a process from the package or from a source install on it? It's still just the Tomcat binary, right?
Because when he installs it from source, the files that he installs aren't going to have the right context on them.
Well,
So
the beautiful thing about Tomcat is you don't need cribs. It listens on 8080, and you give me a user level account, I can be running Tomcat in minutes. And if I open up an SSH reverse tunnel, I'm golden. I can now talk to my buddy Chad.
yeah.
But Chad, he's a really good guy, but he's a little shifty. So if be nice to add a targeted execution policy.
Well, yeah. So you'll either have to look at
Oh, okay.
you either have to look at the existing policy for Tomcat that comes in the reference policy and set the appropriate context
Okay.
in order to deal with that.
For every file that came in.
Yeah, and I'll show you how to do that.
It's like included with your RPM.
Yeah. Well, yeah, and, I mean, it's not included with the Tomcat RPM, it's included with the policy RPM, but anyway.
that's right.
So, all right, so yeah, so things that are started by sort of normal interactive users generally run in unconfined type, and therefore SELinux says, okay, you can do whatever you want. Right? So that's thing one. All right, but, so processes have context. Files and directories in the file system have context as well, and so you can see that with ls-z. So, for example, if I do, I don't know, Etsy and I have rww HTML, right? You can see that different parts of the file system have different contexts associated with them. All right, so var www HTML is the default document root for Apache on Red Hat, and that directory is in HTTP syscontent type. And then the Etsy directory, which is sort of a shared directory, is in this generic Etsy type, right? And again, sort of the naming conventions and the context that have been chosen for all these directories are set in this thing called the reference policy, which is this sort of shared database of people's, policies. Generally speaking, contexts are inherited. So if I created a file under one of these directories, it would inherit the context of its parent directory unless there was a rule that said otherwise. And so I'll show you that a little bit later. And even users have contexts, right? So I can do ID minus D. And you can see that my user is running as unconfined type because I'm just sort of a normal interactive user. And again, out here you can see not only the security level, but you can also see this C thing. Okay, so this is the security category in addition to the level. So if you're really big into multi-level, multi-category security, the reason there's sort of two axes here. So the security level is the secret, top secret kind of axis. The security context, which is the C thing, would be modifiers like proprietary, right? So you could say, that the security level was confidential and the category was proprietary. So confidential and proprietary, and you can get really crazy with that if you want to, but mostly you just stay away, right? So what this is saying is that I'm an unconfined type at security level 0, where everything else is, and I can see all categories from category 0 up to category 1023, which is the maximum category level. So I have open access to the box essentially. Okay.
Your root.
Yeah. But I have open access to the box in an SELinux context, which isn't necessarily the case for root in a sort of role-based access control or multi-level security scenario. Okay. So for most people, though, their main question with SELinux is that frickin' SELinux thing still running or not, right? I mean, so there's the whole administrative interface around, is it turned on, what's it doing, and that kind of thing. And the gateway drug for that is SE status. A little bit here. All right, so the curious thing about SELinux is there's the status enabled versus disabled. Okay, so enabled means SELinux is on and running in the kernel. Disabled would mean it's just completely shut down, it's not doing anything, right? But even when you're enabled, as we are here, there's the mode, which can be either permissive or enforcing. And permissive basically says SELinux is doing its thing and it's monitoring events on the system and it's logging when somebody violates the policy, but it's not blocking. Okay, So that's what permissive is, just log, but don't actually block anything. Enforcing would be actually block the operations, okay? So I have SELinux on and it's enabled, but it's in permissive mode, so it's not stopping me or any of my processes from doing anything. It's only when you go into enforcing mode that things start breaking. Now, interestingly, as of Red Hat Enterprise 6, the default is enforcing mode. I've actually changed the default on this system so that it's in permissive mode by default. So yeah, so Red Hat is confident enough of the targeted policy that they're actually shipping boxes to their customers in enforcing mode by default as of Red Hat 6, which...
As of Red Hat 5.2. I took my RHCT in November of 08. We learned on RHEL 5. 5.1 it was, I think. And it was on by default.
Okay, that's not been my experience with Red Hat 5, but whatever. In any event, okay, so at this point you can see that I'm in permissive mode. How would I set it to enforcing mode? Well, there's a set enforce command. So I can do set enforce 1, or I could say enforcing, but both work, okay? So I'm turning on enforcing mode, and there's also, by the way, a get enforce command, which will tell you what mode it's in. Or you could do SE status again and see that it's in enforcing mode. Now, the changes that I make with set enforce are not permanent across reboots. If you want the default policy to be enforcing when you reboot the machine, you actually have to modify a file called etc sysconfig SELinux on Red Hat machines. And there's this SELinux variable right here. If you want the change to be permanent, you change that to enforcing. Okay. So that will make it so that when you reboot the system, SELinux comes up in enforcing mode by default. Similarly, if you're on a Red Hat 6 box and you want to make sure that it doesn't come up in enforcing mode, that's where you need to change it so that it comes up in permissive mode by default. Or you could just completely disable it if you're never going to use it. The reason we have permissive mode is because when you are developing new SELinux policy for a service, what you do is you let the application run in permissive mode. You collect all the errors about what it's violating. There's actually a tool that's included with SELinux that takes those error messages and converts them automatically into policy allow rules to allow the application to do what it wants. It's a tool called audit to allow, audit number 2 allow. So that's certainly one way that you can kind of get a jump start on developing a policy for a new service that's not included in the reference policy. And that's really why permissive mode exists, for development and testing of new policies. All right, so on or off, permissive or enforcing, right? Those are your choices. And then there's one other administrative interface that you ought to know about, which is SELinux booleans, as they're called. All right, so here's the way this works. You got something big and complicated like a web server, and not everybody needs every piece of functionality in the Apache web server. So there are parts of the SELinux policy for Apache that are essentially optional, and you can turn them on and off by flipping the bits on these booleans, okay? And so if we do get SE bool -a, this will show you all of the booleans that are available for all the different policies. And as you can see, there are quite a lot of them. In fact, let's count how many there are. 173 different booleans, okay? But for example, we could just look at the ones related to HTTPD, and there's still a bunch of those. So for example, yeah, I mean, CGI scripts, right? I mean, anybody still using CGI scripts? Really? Rock on. Okay. The 90s called, they want their web services back.
I'm still using the cell phone from 2000.
Okay, so let's say you wanted to disable CGIs because you're not using them. There's also, in addition to get SE bool, as you might expect, there's also set SE bool, and in this case, we'll do HTTP enable CGI off. And now, you can see that I've titled it off. Okay.
Where
Yes.
do you go to make that permanent?
Okay, so interestingly, the Boolean settings are permanent across reboots.
I love consistency.
Yeah, the wonderful thing about standards is there's so many to choose from.
So that's just stored in some database on the file.
Yeah, that's right. It's stored. There's a policy database in the operating system.
We must remember this came from a government agency.
Yeah, I'm the first person to tell you that, and you'll see this as we go along, a lot of the administrative interfaces for SELinux were clearly designed by people who are not systems administrators. And as a result, they really have a lot of rough edges. And this is one of the reasons I'm kind of on this evangelical mission about SELinux, because the more we get us people using this and submitting bug reports and making feature requests, the better it's going to get overall. Like once the systems administrators have to deal with it, they're going to make sure this crap all works, right? Right now, it is kind of bizarre and cantankerous, and it has all these weird corners in it that you can kind of get lost in. But yeah.
All right, so what you've effectively done here with that rule is it says you disable CGI access for HTTPD.
Right.
Now, that means that you modified the policy.
Right, I basically told the policy that I no longer want the allow rules that allow the web server and HTTPD type context to execute things under, var, www,
Okay,
CGI
and that's the
bin.
policy. Then, in our case, Apache has to then be told to honor that policy, or
No, actually, Apache doesn't get a choice because the kernel's enforcing this. The minute I set that Boolean in the policy, if Apache now goes and tries to execute one of the scripts under var www CGI bin, the kernel says, no such file or directory. It basically,
all right. Is this specific to Apache?
When you're in enforcing mode, which you just changed, if you were in permissive mode, it would just...
yeah, if I was in enforcing mode, you're right, yeah. Is it specific to Apache?
Because I could put a dozen different HTTPD servers. The rule says HTTPD enables CGI off, right?
Yes. So what that Boolean just did is it basically, you imagine the policy with a bunch of if-defs in it, right? And there's a big if-def around the rules that allow access to the CGI bin directory. And I basically just turned off that if-def, so all those rules have disappeared. Okay. But those rules say specifically only, they're only about things in the HTTPD type context interacting with this directory that's in this other context. If you were running your own rogue web server in a different context, like an unconfined context.
It's context specific. That's where I was going. It's
Right.
context specific. But I could add whatever I wanted to that HTTP specific context to make this rule apply to it then.
Correct.
If I wanted to.
Yeah, so yeah, you could, right, yes.
Okay. I just gotta,
Yeah, no, I know.
Getting all
It's
the
like this
terms in my
whole
head,
weird new concept that you've got to shove into your
Context is the
brain.
big thing. It's
Yeah,
all-
so it's all about the context
for
on these
object,
objects.
directory, and file.
Everything.
And then you modify the settings based on these booleans.
Yeah, the Booleans is one way that you
One
can,
way to do it.
yeah. The Booleans, you actually interact with these Booleans not that frequently. Because the policy actually has to be written in such a way that these, if-defs exist in the policy, basically, right? There are a lot of policies that, for applications that have no Booleans associated with them. The policy is the policy, and you don't have this level of administrative control. So for that, you have to do the stuff that we'll be doing in the next section. But the Booleans exist, and you interact with them occasionally. All right, let me just catch up on the slides a little bit. Did that. All right. So next up, troubleshooting. This is the thing. These are the walls that people run into at 90 miles an hour that cause them to turn off SELinux. Right? So, and we'll just do a couple of web server examples because that frequently seems to be the one that blows people out of the water. So, one is, all right, look, the policies that come with Red Hat work great as long as you're doing things the Red Hat way, which means, documents under var www HTML. Well, nobody ever puts the freaking documents under var www HTML. The web developers put them some other random place in your file system, right? So you find that your web developers have moved their document tree to some new partition, and the web server blows up. Like, oh crap! Well, I got to get the web server working. Let me turn off this SELinux thing. Well, no. I mean, there's a way to fix that problem, and that involves making sure that whatever directory the documents are in is in the right context. Okay. And then, or maybe you decide you want to run your web server on some strange port number, and the kernel says, and you say, turn off SELinux. No, there's a way to make that problem work as well. So we'll do these examples, and I'll show you a bit about SELinux troubleshooting as we go along through this, because often the first question is, all right, look, I'm pretty sure that the problem I'm having is caused by SELinux, but how can I be certain? What is SELinux telling me about what the problem is? All right, so I've moved my doc root and I can't start up, right? I've fallen and I can't get up. So what we're going to do here is we're just going to arbitrarily move the document root to some other location, watch the web server blow up, and then go through the troubleshooting strategy to make the web server work again, right? That's all we're going to do. But you'll learn a lot about SELinux along the way. So, here we go. Let's see, is my web server ready? No, it's not running now. Okay, that's fine. All right, so what I'm going to do is I'm going to make a directory. I'm going to call it doc root. It doesn't matter. I'm just going to put an index.html in there for a later example, but it'll be empty. It doesn't really matter what's in it. All right, and then I'm going to go change my web server configuration to use the new document root. So I'll edit etc httpd conf httpd.conf, look for my document root setting. There it is. And I'm just going to change this from var www HTML, which is the default, to /doc root. Okay, and this is the part that drives people insane about SELinux. I go and I start up my web server, etc.init.d httpd start. Okay, syntax error on line 292, document root must be a directory. Now, I mean, you can check line 292. It's the line we just changed to set to /doc root. And you go, well, it is a directory, goddammit. I mean, I can do, ls -ld on this directory and see that it's a directory, right? Okay, so the crazy thing about SELinux is that from the web server's perspective, the kernel is telling it that directory's not there because the directory's not in the right context, right? So from the web server's perspective, you're telling it to open a non-existent directory, and so it gives you this error message, which is the document root you specified must be a directory. Now you can see it's a directory because you're in unconfined context, but the web server, which is running in HTTP context, has no clue at all. And so, yeah, this is the hard part about SELinux. You're getting this weird error message. You have no idea where to begin. I mean, you think it's probably related to SELinux, but because you just put the system into enforcing mode and suddenly your web server bombed out. But how can you be sure, right? Okay, so the place where all of these SELinux violations get logged is the var log audit.log file. That's where all of the SELinux stuff gets logged. So take a look at that file real quick. Okay, now the thing about this file is it's not just SELinux that logs to this file. So it's SELinux plus a whole bunch of other things like daemons starting up, users logging in. I mean, it's just full of cruft. And so what you need to do is pull out just the SELinux related messages from this file. Now, you'll notice that all of these log entries start with type equals something. Okay, so the trick to pulling out the SELinux messages is to know what type those messages are. And there's actually two types of messages that you care about. And so the common idiom that you will use over and over and over again in the SELinux universe is the following. egrep for lines that begin with type equals either AVC or SELinux. Those are the two SELinux type messages, okay? So those are the lines that we care about from var log audit. Var log audit. Access violation condition or something like that. I don't remember exactly what it stands for. But it's actually the more common one of the two. So all of your denial messages are going to be marked with ABC. Now, this will get me all of the SELinux messages out of the file, but really I just care about the ones related to my web server. So I'm going to pipe that into another grep and look for HTTP stuff. All right. Well, I mean, this looks like it might be related to our problem. I mean, I can see path equals docroot in this message, but the rest of it is just completely mysterious. I mean, for one thing, I don't even see a timestamp. I mean, I don't know whether I got this message 3 days ago or it just happened. Right? Actually, there is a timestamp in this message. Can anybody point out the timestamp?
It's the 131.
Yes, it's the big number that starts 131. Yes, it's in Unix epic time. Second since 1970. Again, an administrative interface defined by people who are not systems administrators, right? Okay, so does anybody know the trick for converting epic time dates into human readable dates? Right. Yeah, so there's this magic switch in the date command. So you do date -d @ and then the epic value, and you get a human readable date out of it. All right. By the way, if you read my command line kung fu column, I wrote a whole column on a little shell pipeline that automatically converts all of the entries in the audit log file to have human readable dates, but that's a whole other thing. So yeah, so date -d @ and you can see that the date on this entry is pretty close to the time my virtual machine thinks it is. So this just happened, okay? So yeah, this is the error message. What's it saying here? All right, so we're getting a denial message on get attr, which is basically the stat system call, okay? Because really what SELinux is controlling is system call access. I mean, that's the bottom line. The kernel is basically saying this object is allowed to do this system call to this other object, and that's what's going on here. All right, so basically the kernel is denying this stat on by PID 7541, which if you look was our web server process.
For the 0.5 seconds you tried.
Yeah, but if you look in like the Apache error logs, you'll see the PID. And it's the HTTP daemon. Okay, that's good. Path docroot. This actually identifies the document root object. It's on device SDA1 at inode 32771. Okay. That's important from the kernel's perspective, not that helpful for humans. The interesting stuff here is towards the end. So you see S context, okay? So this is the source context. So it's the context of the HTTP daemon that was trying to access the object, okay? And the object's context is the target context that you see here. So I started the HTTP daemon, so it was running as unconfined view system R HTTP type. And apparently the /docroot directory is in that context. And we can actually observe that if we do an ls-dz on it. You can see that the context on that directory matches the target context in our error message. Okay, so woohoo! We actually sort of have an error message that's definitely telling us that SELinux is at fault here, making the web server blow up. Okay.
Can you do the LSDZ on var www HTML?
You're one step ahead of me, but certainly let's do that, right? So, all right, what's the solution to this problem, right? The solution is the web server worked fine when things were when the documents were living under var www HTML, right? So obviously there's a policy rule that says the web server is allowed to access files under that directory. So it would seem to me that yes, if we set the same context on our doc.root directory as is currently on var www HTML, then the web server should start up. Okay? So yeah, you're exactly right. Let's look at the context on var www HTML, which is the default document root, and then let's change the context on our new /doc root to match, and things should work. And that's an absolutely valid, troubleshooting strategy for this, right? Right?
All right.
No buts. I mean, it's the way I'd solve this problem. So, all right, so great. We know what we want to do. I haven't told you how to change context, though.
That's the 64,000
Right.
How do we achieve?
Okay, so it turns out there's two ways to do it. There's a right way and a wrong way. Yeah, and I'm going to show you the wrong way first, because the wrong way is the first one you're going to go for. You think, okay, so, I've got chmod to change permissions. I've got, chown to change ownerships, chgroup to change group ownerships. Chkan is exactly right, actually. It's the name of the command. It's Chkan. So there's Chkan, which works. Chkan! Yes, exactly.
That makes change also known as change context.
All right, so let me get this to the top screen. All right, so the doc root and var www HTML, and what we got to do is we got to get the system view object or HTTP sys content type context onto /doc root. All right, so you can do chkan -r works just like all the other commands on Unix, right? So R for recursive. And then you just, set the context, right? So we're going to literally copy and paste this whole thing onto /doc root. And that's really all there is to it. And now you can see let me do it recursively so you can actually see it change the file underneath. That it got not only the top level directory, but it also got the file underneath. Okay, so everything's in the right context, right? So I should be able to start up my web server and it should just work. And indeed,
The web server I expect to start up.
yeah,
Maybe I'm wrong, but
no, it'll work.
you're going to add some web pages at some point. Are you going to have to do that chcon on them also, or because they live in doc.root, they automatically inherit?
Right, yeah, so remember what I said about inheritance, right? If I create like foo.html under doc.root, it's at least an HTTP sys content type. It didn't pick up because I'm creating it from my unconfined role.
Right.
It picked up my user role portion of the context, but at least it got the type right. Which is really all we care about.
Yeah, because of the way
Yeah.
SELinux is currently configured, it's basically only paying attention to the
Right.
third element.
Yeah. Now you'll see when we do this the right way that the right way actually fixes that problem as well. But let me just show you that, in fact, I can start up the web server. Woo! Okay, so you're like, okay, so here's the problem. See, SELinux context is this whole other bizarre universe. And you have problems like, your backup utilities don't always get the context information associated with the files. So let's assume that you had sort of a catastrophic failure where your document root got blown away and you had to restore it from backup. Let's just simulate that, shall we? So let me go up to the root directory. I'm going to quickly tar up my document root, docs tgz doc root. Okay, and then I'm going to remove my existing document root. And then I'm going to tar zxf docs.tgz. And what you'll see, of course, is that all the contexts are back in the old, messed up, broken contexts. Right? So that's the problem, right? After like a catastrophic event, like a system restore, all your contexts are going to be messed up.
Because they're not stored in the inode like all the other.
Well, no, actually the contexts are stored in the inode in an extended attribute, but your backup utilities don't typically back up the inode. They just back up a few selected elements of the inode that are important to the backup software. Right? Now, it actually turns out that tar on Red Hat has a capital Z flag that backs up the contexts, but commercial backup utilities have no freaking idea about this, right?
This isn't cap Z compressed.
No, little z is little
Capital
z.
Z though, I thought ran compressed and lowercase e ran G's.
I think they took.
Oh yeah, that's true. Actually, hold on a minute.
Over time.
There is an option to store SELinux context in tar on Red Hat, but the point is there are events that will knock the contexts off of files like this.
-- SELinux.
Oh, awesome! --
There's no
SELinux.
short options on the line.
So.
Without short options.
So, yeah, I mean, I could go back through my file system now, and let's suppose I had to restore the entire file system, right? I would have to go through and manually set SELinux context everywhere? I mean, that's just not workable, right? Okay, so this is why Chicon isn't necessarily the right way to do this, because yes, Chicon will get you past the sort of short-term problem, but long-term, you've got this sort of administrative issue. So the right way to do this is actually to update the SELinux policy database. Okay, so in the SELinux policy database, aside from the rules that say this thing's allowed to talk to this other thing, there are default context settings for files and ports and other objects in the operating system. So for example, you look at all this stuff via the SE manage interface. Okay, so the command to deal with file context is SE manage f context, and I'm just going to do L to list all of the contexts, and then I'm going to grep for the ones associated with var www.
Well, so that's going to show you every context for every file policy.
No, what it's showing us is rules associated with objects under var www, and there's a lot of them, as you can see. Okay, so the advantage, though, if I create a rule for my document root that sets a default file context in the SELinux policy database, is that I can then, there's a separate command to apply those rules. So there's SE manage, which allows you to create rules for file context. There's restore con, which simply looks at the policy rules for whatever directory you're restore conning and sets the context appropriately. So the right way to do this is a two-step process. You create a policy rule about your new directory, and then you use restore con to set the context on that directory. The advantage being that if we do have a catastrophic event that blows away our entire file system and we have to recover it from backups, I can simply restore con from the root, and it will automatically set everything according to the policy database. In fact, if you touch a file called .autorelabel under the root /.autorelabel and then reboot the machine, it automatically restore cons the entire file system during the reboot. Now you don't want to do that often because it takes a while, right? I mean, this is a slow, 15-minute kind of event, right? But yeah, if when you restore your file system, onto a bare metal machine, the last thing you do after the restore is you touch /.autorelabel and reboot so that it resets all the file context for you. Right. So what we want to do is we want to create a policy rule that sets the appropriate context on our document root directory. And so it's SEmanage fcontext, add a rule, okay, and we're going to apply type HTTPD, what is it on? Just get this right. So we want to make sure that our document root ends up in HTTPD syscontent type. So we're going to do SEmanage fcontext, add type, that type to, okay, and this is where it gets a little bit weird, because we actually want it to apply not only to the doc root directory, but everything underneath it. And in order to specify that, you get to use regular expressions. So we actually need to do a regular expression, which is /docroot, and optionally, docroot followed by a slash and anything. Okay, so that matches not only /docroot, but also all paths underneath /docroot. And that's the way you write these rules. So if you're good at egrep, you're good to go.
You couldn't just do /docroot dot star.
No, because that would actually match.
Docroot 2, docroot 2.
Yeah, right, exactly. Yeah.
Oh.
Yeah. So, I mean, now if that's what you meant, then yes. But generally, you want to be as specific as you possibly can be. All right. And so I hit return, and I wait. Because what's going on here is that the SELinux policy database is in this sort of compiled binary format. And of course, the policy rules also need to be updated in this sort of big blob of binary data. So there are these pregnant pauses when you do these commands to update the policy database.
So is that why when you do the updated policy, it always takes forever?
Yeah, right. So, right, when you get a new policy update from Red Hat, it's because it's recompiling the policy, right, essentially. Yeah. Okay, and now, actually, we can actually see this, right? So if I do SEmanage fcontext -L, pipe to grep /docroot, you can actually see that my setting was taken up into the policy database. So that, however, did not actually change the context on the doc root directory. Remember, it's a two-step process. To change the context on the document root, I have to do restore con, and again, it has a -R option. Right? And I'm going to do VV, which is the most verbose, so that you can actually see what it's doing on /docroot. And you can see that it goes and it sets the appropriate context on not only the doc root, but also the two files underneath. And now, again, I can restart my web server. And it starts up just fine. Okay. All right, so that's really the right way to deal with file context. And I mean, this is a perfectly valid troubleshooting strategy. I've moved an operating system resource from a location where the policy expected it to be, i.e. var www.html in this case, to a new name, /docroot. So all I got to do to make the policy work for the new name directory is set the right context on the new directory, because it's all about the context. It doesn't, the location of the object in the file system or the name of it in the file system doesn't matter. What's important from an SELinux perspective is the context on the object. And you can have multiple objects in the file system that all have the same context on them. That's perfectly okay.
Can you show the error message in the audit log again?
Yes.
And that error message had the source context and the type or the
target
context.
context.
The target context.
Yeah.
And so the issue is that the source context didn't match the target context.
No, the issue is that there was no policy rule that allowed something in this source context to interact with an object in that context. And since there was no rule,
The confusion I have is that the context we ended up setting on Docker is not either of the ones that were listed in that error message.
that is correct.
So we had to figure out what context was appropriate. The error message didn't tell us what context
Right.
would have worked. It just told us the one that didn't work.
Correct. The error message doesn't help you solve the problem. It just it tells you that SELinux feels that this is a problem. And it's up to you to figure out the right way to make the problem go away.
I'm sure the first version probably just gave you a question mark once you figured it out.
So it's an
Echo bailing out near line 1, exit 255. Yeah, I mean, yeah, right. I mean, the best we can tell from this error message is that SELinux thinks that this is a problem. I mean, that's all you get.
And why is the, okay, so the context we set on that Docker is HTTP sys content T,
Yes.
but the source context on the web server itself was just
HTTP type. Right.
type.
So
And that's
generally,
because one's a directory, one's a process.
yeah, I mean, it's just the naming
You
convention.
can name it.
Right, I mean, but yes, generally the naming convention is if the process is HTTP, then the type that process runs under is HTTP underscore type. But that process may interact with files and directories in a variety of contexts. So for example, if you look at all the different things.
More than one.
Yeah, right, so if you look at, for example, LD, or at least DC, var www HTML, and etc HTTPD, which is the configuration directory, you can see that one's in config type, which is conventional, and one's in syscontent type, right? I mean, and the actual Apache binary itself is in yet another context. It's an HTTPD exec type context, right?
With corresponding policies for each.
With corresponding policies, because you do different things in each directory, right? So yeah.
You wouldn't want to execute a file in a config directory.
Correct. Yeah.
And you wouldn't
And-
want to allow the executable to alter itself like it would with its log file.
Right, for
That's
example.
going to be a different type.
Right. So yes, exactly.
Underscore
So
log or whatever.
right. So if
It's going to be able to write to that log file. Well, you don't want to have it be able to write to its own executable, because then if somehow somebody does get in, they get
clobber the executable. Yeah, you got it, exactly. So yes, we put things in different contexts so that we can apply different policies to each of those locations.
Back to good old days of self-modifying.
So how do you figure out if you don't have the evidence trail file context type from that directory?
You look at the reference policy source code. You download the source RPM, and you read the source code, because that's all you got. I mean, I'd like to give you a better answer than that, but right now the state of the world is that you reverse engineer the source code. I mean, now Red Hat does make the source RPM available, and in fact, you know, in the day-long class when we get into writing policies, we basically do it by reverse engineering the source RPM. So, but yeah, no, I mean, it sucks. I mean, you got to learn how to read the policy statements. All right, so that's file context. The next example is port context. All right, so you've decided that you're going to run your web server on some strange port number, and
25.
for example. Let me do a different port, one that's not used by another application. All right, so what I'm going to do is I'm going to edit my httpd.conf file again. And looking for the listen directive this time. I'm going to tell it to listen on 1337, because I'm lead. All right.
We're too old to use that.
And now, of course, when I go to start my web server,
Restart.
There's no firewall context at this point, correct? Because it would, well, I guess you're binding to all ports.
Do you typically run IP tables and SELinux at the same time?
yep.
Oh, yeah.
Why not? If you want to.
SELinux is a crazy, crazy world. I don't know what they do.
All right, so yeah, boom, right? You know, we try and start up and it fails. And of course, you know, the error message again is mysterious, right? Could not bind to address, blah, blah, blah. Now, normally, when I see that, I think, oh, there's something else using that port, right? I mean, that's the normal sort of Unix failure mode. But, you know, you run LSOF or netstat and you see there's nothing listing on that port, and you think, oh, it's that SELinux thing again, right? Con! But again, how can you be certain? You check the audit log, right? I mean, so we do that crazy egrep thing again. And indeed, you know, we now see a slightly different error message here. Yeah, two of them, in fact. Yeah, so denied name bind. Okay, binding to a port could be right. You know, HTTPD, and notice now, this is really unhelpful, by the way. The port number is listed as source equals. Well, okay, it's not really the source. I mean, because the source context in the error message is, of course, the context of the HTTP daemon. It's the target, really. Anyway, this error message is messed up from my perspective. But again, not designed by administrators. So yeah, so what we've got is the HTTPD, which again is running an HTTPD type context, is trying to access this TCP socket thing, 1337, which is in this context. All right. Great. All right, so it's probably, again, related to SELinux. All right, so we used SEmanage F context as the sort of entree into dealing with file context. So now we're dealing with port context. What do you expect the command to be? Yeah, so you think, oh, SEmanage P context, and you'd be wrong. It's actually SEmanage port. Yes!
Different person, different days.
Yeah, so it's SEmanage port minus L will list all of the port assignments. And you can guess that the port is probably HTTPD something type, right? So we could grep for HTTPD, for example. You could also just grep for port 80, you know. No, guess not. It's actually HTTP is the confusing part. Yeah, you know, I was not consulted when these names were chosen. All right, and you can see here, you know, port 80 is in this list of ports which are in HTTP port type. Okay, so if we want the web server to be able to listen on 1337, it seems to me that we ought to somehow manage to get 1337 in this list of ports that are in HTTP port type. Okay, and you might extrapolate from the previous example with file context that you would do something like SEmanage port add type this type to 1337, and you'd be wrong because you also have to specify the protocol with P. Okay.
That I can see.
You know, but like, you know, if I were designing this interface, I would have it be just, you know, AT blah 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 1337/TCP. But hey, that's just me, you know.
Well, since TCP is called out in the second column, it seems like you shouldn't use it at all, unless you were trying to build another line in the file.
Whatever. This is the right way to do it.
Just so you have something else to complain about.
Exactly.
Because there isn't a Unity version of HTTP 14.
Yeah, so you might want a second line.
Yeah, but then I'd just say 1337/UDP. I mean,
Yeah.
Well, what would if you did put in UDP, is it going to build a separate line, or is it going to divide that out?
no, it'll appear as a separate line in the output of SEmanage. All right, so yeah, insert Jeopardy theme music here, right? Do 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 do. We're updating the binary policy. Do 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 do. Do 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 do.
The dash bar would reveal existing
Is there a way to batch the policy updates, so if you're like making more than one change, you don't have to waste as much time?
No, I could put it in a loop in the shell and have them, so I can go for coffee while it's doing it. Actually, I mean, so yeah, there is a way that you can create policy modules that you can sort of load in chunks, okay? But for this kind of thing, no, you typically do it one SE manage command at a time.
When that's running and taking forever, is that a highly disk?
No, actually, I mean, it's really not a big load on the system. It just takes a bunch of time, right? It's just like, okay, got to unpack, make a change, pack it all back away kind of thing. But I mean, we're not talking about a lot of I/O here.
I just wondered what it's sucking up CPU or disk.
No, it's computation.
You wanted to remove 8,009.
Yes, okay, so let's talk about that, right? All right, so first let me show you that it's actually in the right place. All right, so there's our port, right? And now, again, I should be able to start up the web server, right? And hooray, we're running. Okay, so now you say, all right, I'm running my web server on my LEET port, and I don't actually want the web server to be able to bind to these other ports, right? I want to clean up the list. I want to make the policy more restrictive. So you say, all right, SE manage port, and it's -D to delete rules, and that works for both files and ports, right? Okay, so it's A to add, D to delete. And we're going to delete from type this 8009.
You don't have to specify.
Oh, and of course I need to do -P TCP, right? Oh, fail! Okay, so what goes on here is that these default ports that you see here are actually compiled into the reference SELinux policy. And in order to remove them, you actually have to go in and edit the policy source code, recompile it, and load the whole policy.
Really
But-
change the policy.
But you could remove the LEET one that you put in, because that's...
Yes, but I can remove the one about
Right, okay,
1337. That one's
What
okay.
happens if you do that while your web server is currently running?
Let's find out.
1337.
Yeah.
What do you predict's going to happen?
It's going to tell you that 1377 isn't needed there.
1337.
Not quite neat enough.
Yes, I'm apparently not lead enough to type the right port number. So what do you think is going to happen?
I bet Apache is still running.
I'm assuming that Apache is not going to be able to access the port.
But Apache's already bound to the port.
It's
That's
fine
true.
until you try to stop it.
That's like deleting
Correct.
a file when somebody's got it open.
Exactly.
They can
Right.
still do whatever,
Right.
but nobody else can.
Yes, but the minute Apache restarts, it's going to blow up, right?
Right.
So that's the issue, right? Remember, the kernel is blocking basically system call access here, and so Apache's already made the system calls to bind to
Yeah,
that
it's
port
already
and got it
got the port
open.
open, so
It's only when the server
it can block
restarts
this
that things are going to go wonky. So yeah, so indeed, like I can telnet to port 1337. The Apache server is still there. Of course. Of course, I don't have telnet anymore because it's a modern Unix system. But I can, netcat to that port and get connected to it. It's all good, right? Of course, index.html is empty, which is why I got an empty response back. But yeah, the minute I go to restart the server, we're going to get the same failure that we had before. It's not going to be allowed to rebind to that port. So. So yeah, so no, you can't delete the default ports without editing and recompiling the policy.
Because I can see where somebody might fall into that hole. It's like, I'm going to clean all this stuff up because I don't need it.
Yeah,
And
the
then-
first command they enter just like blows up, right? Great, awesome.
What are all these under /bin? I don't need them. I'll go ahead and remove them.
Yes, that's right. What are all these crazy things under /dev? I never use those. I'll clean that up. That'll be fine.
Taking up lots of disk space with all this crap.
So, I mean, that is really the basics of SELinux troubleshooting, right? So what have we learned here? Varlog audit log is where all the error messages pop up. You want to look for the type ABC and type SELinux messages. Of course, they're written in this crazy log format where you have to convert the timestamps and puzzle out what it's telling you. But as we talked about, it doesn't actually tell you how to fix the problem. So fixing the problem boils down to setting context, right? And so if the service was working when the directory was some other place, then you figure out what the file context was on that directory, and you just copy it to the new location using semanage fcontext and restore con. Or if it's a port issue like we just dealt with, then it's semanage port to add your port to the appropriate, context. Really, if you know that much, you can manage a system that's running SELinux. I mean, that's really, like 80% of the battle, to get SELinux going. The rest of it is creating policy for new services that you sort of bring into your environment, and that's a huge thing. I mean, that's difficult. Let's see, it is 8 o'clock. I've been talking for about an hour and a half. If policy would be, we'd be here another 2 hours, so we're not going there. But any questions about the stuff that we've covered so far?
If audit D isn't running, you're not going to be logging that information.
Right, so audit D's got to be running to get the logs in the audit log.
Is there a difference between SE troubleshoot D and audit D?
Yes. Okay, so audit D is the thing that actually gets the SELinux errors from the kernel and puts them into the audit log. SE troubleshoot D is the thing that makes the little pop-ups appear on the desktop, that say, "Whoa, you just got an SELinux violation," right? Which I don't find useful. But yes. Other questions?
Context will also stick too. So like if you unzip something in your home dir and move it into the web dir, it'll still be user home D instead of hard or HTTP syst. So that's one thing to watch.
Okay, so that's
okay.
That's true if you move the file within a partition because it keeps the same inode.
Okay.
But if for example you move it from your home directory, which is one file system, to var, which is a different file system, it's going to pick up the context of the directory that you move it into because a new inode is going to be allocated there, right? So always remember that the context is in an extended attribute in the inode. So yeah, I mean, as long as you don't change the inode, then yes, the context goes with the file. But the minute you move into another file system, you're going to grab a new inode, which means
Of course,
you're
the
going
way
to
to get around that's not to do the move, but to do a copy. Because then it will pick up that inherited entity.
When I Google SELinux tutorial, the first 5 hits are from 2007 and before. Are they good?
No.
Or are they crud?
No, I mean, so the problem is, okay, the state of the documentation for SELinux is abysmal. The SELinux community has been going through this sort of rapid development cycle. It's mostly organized by a company called Tresis, T-R-E-S-Y-S. And they're the repository for the mailing list and the reference policy source and all of that. And they have documentation, but basically the documentation is simply auto-generated from the source code. I mean, there's no real explication or tutorial there. And all the tutorials that I found about SELinux predate the sort of current targeted policy, reference policy implementations that we're using on modern systems, so they don't reflect the reality that you guys are going to be interacting with. So, no, unfortunately, all the documentation is really out of date and scanty anyway. So, yeah, somebody ought to write a book.
They wrote 2. Traces wrote one, which didn't sell well, and O'Reilly did one too that also didn't do real well. That was back 2006, 2007.
Yeah, right.
They're one of the
There's a
biggest.
current SELinux.
Yeah.
The second great coming of SELinux. The
Yeah.
first one being 2001. The
So-
third one
It's actually a current SELinux book, I just can't remember who wrote it. I've got a couple people.
Let's talk to.
So the best documentation out there for SELinux is the Red Hat documentation. There's some documents in the Red Hat Enterprise documentation tree, which you can get at. There's also the Fedora SELinux wiki, which has probably the most current documentation, and it's pretty good, you know, ish.
Are they still doing that?
SELinux by example is the book.
What's the publication date on it?
O'Reilly 2007, I think.
Is that?
It's
Is that
pretty
the
sure.
one, the blue one?
That's the Traces one. There's a red one which is managing SELinux. But are they still doing the SELinux symposiums? Because they did one in 2007, which was like a combination. They did release the notes for it, which were really a great resource. I don't know if they're still doing it as part of Pomeranz Commission or not.
I have no idea, to be honest with you. I was on the mailing list for a while, but it was too high volume, and I was just, okay, I don't have time to pay attention.
Too much whining?
No, actually, no, really, I mean, if you're focused on developing SELinux policy, it's a really good mailing list to be on, but that's all they talk about all day long, constantly. Really, guys, get on IRC. No, I mean, so, yeah, but I just, because I'm not currently working a contract where SELinux is my entire responsibility, I was just proc mailing it into a folder and not looking at it anyway, so I unsubscribed.
So, outside of getting the book and digging into these, how does like NFS mount points play in all this?
Oh God, well see, so yeah, SELinux pretty much, again, think of the context it came from, right? NSA, they don't do networking in the NSA. I mean, network file systems don't live in that universe, because that would be sharing information, which is, not what they want. I mean, so their concept was a single box that, is its own little universe. So you'll find that when you try and do SELinux across typical network file sharing protocols, including NFS and Samba, it just doesn't work because the contexts don't come across, right? So yeah, you're bummed, basically, if you want to do SELinux in a network file sharing kind of universe, right? Yeah, I mean, I suppose if the files that you were sharing were on another Linux box.
Well, yeah, I'm not talking sharing out from SELinux. I'm actually talking like reading it in. So I have some standard NFS server out there. Call it NetApp. Call it my favorite
Still
line
wouldn't
system.
come over the
And all it's
wire.
doing is sharing out NFS like web pages or home directories.
There aren't going to be any context on those files. So at best, SELinux would treat them as being an unconfined type, but actually, I'm not sure what's going to happen in that situation. Probably the services that are running in something other than the unconfined type, like HTTPD, are not going to be able to interact with those files because there's no rule which says that those processes are allowed to interact with those unlabeled files, and so it's probably going to blow up. Target file system. I'm sorry?
If the file server has SELinux on it.
But the information isn't.
It doesn't come across the NFS
Yeah,
protocols.
the problem is that the NFS calls aren't going to pass, even if you could set them on the remote end. I'm pretty sure that,
Yeah, it wouldn't be.
See, the NFS protocol doesn't have a place to include that information.
If I were to set the appropriate protocols,
It's just not gonna exist.
policies on the client machine.
Which means diskless workstations are pretty much
I mean,
toasty.
Would Ed see that block the ones that should be blocked? You're the ones that should be left.
but haven't you set the policy? I mean, the things that you're trying to interact with don't have labels on them. So the only policy you could create is yes or no. Yes, you're allowed to deal with unlabeled things, or no, you're not.
Isolating it.
Right?
Okay. Well, I'm talking about
Yeah, it's part of the package.
something that's coming in. Try to replace if my mount partition is on
From the mount point
remote
down,
system,
it's, everything's got to be the
now
same thing.
83 document. But from the the client policy SELinux is set to allow things from now 83.
See, the thing is, that's not the way policy works. The policy allows things not based on where they are in the file system. It allows things based on the context that is set on that object. And there isn't a context on that object, so I can't control it.
I don't know what it is. Okay.
So, as I was talking with Chad, SELinux is pretty hard to implement with the business workstation.
One of the things you're trying to do is you're trying to be able to scale.
Yeah, right.
Because everything's in a Facebook.
Yeah, but who uses disk as workstation? Really?
We came full circle.
Okay. Not my world.
I personally love them.
Do you
If
have,
you're moving parts of the machines.
do you know of any
for
people that are still using AppArmor? To talk about another kind of
Yeah,
access
all right,
control
so,
system?
yeah, so let's talk about that. Okay, so there are other kernel-based policy enforcement mechanisms out there. GR Security is one, AppArmor is one. So the situation is that SELinux is the one that made it into the kernel, right? I mean, there was a big showdown, and it's a big, come to Jesus meeting about, which one of these type enforcement systems are we going to put into the mainline Linux kernel, and SELinux won. And there was a lot of political maneuvering around that, but whatever. I mean, the fact of the matter is, SELinux is the one in the kernel.
Well, Smack's in the kernel too.
And I thought AppArmor got in too.
AppArmor got it.
Really?
Yeah.
Actually, Ubuntu uses AppArmor too now.
Yeah.
Yeah, they do. Now, so here's the thing, right? So the group that was developing AppArmor was actually at Novell. It was a group that was headed by Crispin Cowan. Novell jettisoned them a couple of years ago. Crispin actually works at Microsoft now. And I don't know. I mean, what's the future for AppArmor? I mean, yes, there is still a development team that is working on AppArmor, but I fear that it's going to become abandonware without sort of significant support behind it. Now, I mean, I will say that from a user interface perspective, AppArmor kicks SELinux ass, right? I mean, it's much easier from a sort of policy development perspective, but I'm not sure it's getting the resources to be sort of a long-term thing, right? I don't know. I mean, yes, Canonical is still, supporting AppArmor, but on the other hand, they've also been making noises about incorporating support for SELinux as well.
Well, Debian's got SELinux, so it makes sense.
Yeah. Gentoo is big in SELinux.
Well, I mean, just Debian's, which is nothing but a rip-off of
Yeah.
Debian. It's going to have to inherit it.
Ubuntu, African for easy to install Debian.
To make this much easier for Joe Average, somebody just needs to write a nice, Python.
I think they've tried a few.
There's been a couple tries.
So what about this common interface?
Right. So there's a SELinux tool called Slide, the SELinux Integrated Development Environment, which is a GUI-based IDE for developing new SELinux policy, for example.
Okay, I was talking more about just the normal management, like you're doing from command.
Yeah, and
You know how
they're
scared some people are of typing stuff on a command line for whatever reason.
yeah, right.
They don't understand man pages.
So yeah, so you're right. I mean, yeah, it'd be nice if I could just say drag this context onto this directory
Point,
and have
click, drop down
Yeah,
menus, yada, yada, yada.
right. So yeah, sure, I agree.
And if I was to do it, I would integrate something to a brief audit log, and do basic interpretation.
Yeah, that'd be good too. There actually is there's a little utility that I didn't show you called Audit2Y. So let's do that egrep again. I could pipe this into the magic Audit2Y command, which is really audit to allow -W, but. And it tries to give you a little bit more English-like interpolation. So, it shows you the error message and
Was caused by.
I'll peel you double
but of course,
white
this is
fine.
yeah. I mean, this is completely wrong, as it turns out.
Yeah, you're not doing anything with yellow pages.
So,
Oops.
but you could imagine somebody doing a better job of this, right?
I could imagine me doing a better job.
I could imagine my cat doing a better job of this. But anyway. But you're right. I mean, and this is why, again, I'm trying to get people to sort of start using it. So they say, why the hell don't we have a nice, graphical front end for, Joe user to, be able to control this thing? I don't know, because it was made by security wongs, not administrators.
Why government employees that have no restriction on how many hours they spend?
No, I think it really is because it was made by people who care very much about sort of the security model, and to them it makes sense, but to normal people who don't live in that universe, yeah.
A lot of these security
measure out
makes
there
sense
how
to
much
me.
this is used.
Usability.
Netcraft, track how much Apache is used versus IIS.
Yeah, I have no data on how much it's being used. I will say that actually the reason I developed this one-day course is because I've been approached by a large contractor to educate people on how to use SELinux, which means that their customers are asking for it, which means there's a market for it somewhere. So I think people are slowly starting to adopt it, mostly because I think they're finding that their current security mechanisms aren't working for them, and they're willing to, give this a try. So. Alrighty.
Hooray!
So what are you talking about next month?
Part 2.
I will be in San Diego on vacation with my wife during next month's OLUG meeting.
Good for you.
So I will not be here.
When are you coming to town again?
He watches the videos.
I want a tutorial of that caliber on UDEV.
Yeah.
I'm actually not the guy to give you that tutorial.
How many people use Dropbox?
I want to do Sparkle Share.
Well, maybe we should talk about that next month. Make your own Dropbox with Sparkle Share.
Yeah, I need to check out Sparkle Share, download it, play with it, etc.
I've been running it for about 3 or 4
What
months
is
now.
Sparkle?
What's it called?
Sparkle
Sparkbox,
Share.
Except you run the Sparkle.
Share.
Sparkle Share.
Yes. It's essentially,
Sparkbox, except you run the server.
you get Git and another program that talks to Git and some SSH stuff. In fact, there was a new version.
Things with NFS with cache.
Delete a file in your Sparkle Share folder and then restore it, or bring out a different version of it.
Oh,
Yeah, so it has Git versioning.
version control system.
Yeah, but like it's running on my laptop and my Pogo plug at home. So change on my laptop, the Pogo plug changes.
Oh,
Yeah,
that
change it on the
is
Pogo plug,
how it gets,
laptop changes.
Yeah, that's where the usefulness comes in. Okay.
Yeah.
It,
Now, there's a concert that night too, so hopefully we can get through it pretty quick.
Who's the concert?
They might be Giants. We'll be at the Slug.
you ever seen Hookshot?
No, I have not.
Okay. You got ECD or something. 4 songs.
Well, thanks for being here.
Thanks, Halby.
Thanks for having me again.
Same old stuff. I got nothing else. Sparkle Share next month. I know it's an odd name.
It sounds like a toilet bowl cleaner. What are you doing here? I gotta say,
It cleans the Git out of
a lot of
your
stuff in Linux that's got really stupid names.
I understand, and,
That one of my biggest problems with, allowing anybody and everybody to make stuff in Linux is they come up with really stupid names.
Well, no, the problem is that all the good names have been taken, and so you're
Yeah.
left with choosing
You
kind
just
of
start removing the
bizarre.
vowels.
Hey,
Can you come to the bar next door and have a beer?